Look up at the night sky. What do you see? Stars, right? But there's so much more. Those twinkling lights are just a tiny part of something bigger. I'm talking about galaxies. These cosmic giants are the building blocks of our universe. They're like cosmic cities filled with billions of stars, planets, and mysteries waiting to be solved. Why are galaxies so important? Well, they're the largest structures in the cosmos. They shape the universe as we know it. Galaxies are where stars are born, live, and die. They're where planets form, where life might exist. In a way, galaxies are the cradles of everything we know and love about space. Our home, the Milky Way, is just one of billions of galaxies out there. By understanding galaxies, we're really understanding our place in the cosmos. So what exactly is a galaxy? Think of it as a cosmic metropolis. Just like a city has buildings, streets, and people, a galaxy has stars, planets, and cosmic dust. But instead of covering a few square miles, galaxies span thousands or even millions of light years. At the heart of most galaxies is a supermassive black hole. It's like the city center, influencing everything around it. Surrounding this core are billions of stars, each potentially hosting its own family of planets. These stars aren't just scattered randomly. They're often organized into beautiful spiral arms or elliptical shapes. Galaxies come in all shapes and sizes. Some are massive, containing trillions of stars. Others are dwarf galaxies with just a few billion stellar inhabitants. Each type tells us something different about the universe and how galaxies form and evolve over billions of years. How do these cosmic cities come to be? It all starts in the early universe. Imagine a vast, almost empty space filled with tiny ripples of matter. These ripples, left over from the Big Bang, are the seeds of galaxies. Over time, gravity pulls this matter together, forming the first stars and proto-galaxies. Some collapse into disk-like structures, forming spiral galaxies. Others become more rounded, turning into elliptical galaxies. This process isn't quick. It takes billions of years. Galaxies often collide and merge, creating even larger structures. It's like a cosmic dance, with galaxies twirling and combining across the vastness of space. New stars are born in clouds of gas and dust. Old stars die, sometimes in spectacular supernova explosions. When we look at distant galaxies, we're seeing them as they were billions of years ago. Now let's zoom in on our own cosmic neighborhood, the Milky Way. This is our home galaxy, a vast spiral of stars, gas, and dust. It's a magnificent structure that has fascinated astronomers and stargazers for centuries. On a dark night, you can actually see it stretching across the sky. This glowing band of light is a sight to behold, a reminder of the vastness of our universe. It looks like a milky band of light, hence the name. This band is composed of millions of stars that are too faint to be seen individually. The Milky Way is huge. It's a colossal structure that spans an incredible distance. It's about 100,000 light years across. To put that in perspective, light travels at about 186,000 miles per second, so you can imagine the vastness. And it's packed with stars, somewhere between 100 and 400 billion of them. Each of these stars could potentially have their own planetary systems. Our Sun is just one among this vast stellar population. It's a relatively average star in terms of size and brightness. Our solar system is actually about 2/3 of the way out from the galactic center in one of the spiral arms. This location provides us with a relatively stable environment. We're in what astronomers call the Orion arm or local arm. This is a minor spiral arm, but it's our little corner of the galaxy. And what's at the center of our galaxy? A supermassive black hole, of course. This black hole is a mysterious and powerful force. We call it Sagittarius A*. It's an object of intense study and fascination for scientists. It's about 4 million times more massive than our Sun. Despite its massive size, it's incredibly compact. Instead, it acts like a cosmic anchor, its immense gravity helping to hold our galaxy together as we spin through space. This gravitational force is crucial for the stability of the Milky Way. Section 5. Unveiling the structure of the Milky Way. Let's take a closer look at the structure of our galactic home. The Milky Way isn't just a flat disk of stars. It's a complex, three-dimensional structure with several distinct parts. First, there's the disk. This is where most of the action happens. The disk is where you'll find most of the stars, including our Sun. It's also home to vast clouds of gas and dust. the nurseries where new stars are born. The disk isn't uniform, though. It's divided into spiral arms, regions where star formation is particularly active. At the center of the galaxy is the bulge. This is a dense spheroidal region packed with old stars. Surrounding the disk and bulge is the galactic halo. Section 6. Stellar neighborhoods and cosmic dust. Within the vast expanse of the Milky Way, stars aren't evenly distributed. They tend to cluster in what we call stellar neighborhoods. Our Sun, for example, is part of the local bubble, a region of space about 300 light-years across. These stellar neighborhoods are fascinating places. Some are dense clusters where stars are packed close together. Others are more spread out. Some are home to young, hot stars that shine bright blue. Others contain older, cooler stars that glow red. Scattered throughout the galaxy are vast clouds of gas and dust. In these clouds, new stars and planets are constantly forming. The famous Orion Nebula is one such stellar nursery in our galactic backyard. Section 7. The mysterious dark matter. Now let's dive into one of the biggest mysteries in modern astronomy: dark matter. We can't see it, we can't touch it, but we know it's there, invisibly shaping our galaxy and the entire universe. How? Because we can see its gravitational effects on the things we can observe. When astronomers look at how galaxies rotate, something doesn't add up. Based on the visible matter, stars, gas, dust, galaxies should fly apart. They're spinning too fast for their own gravity to hold them together, but they don't fly apart. Something invisible must be providing extra gravity. That something is what we call dark matter. Section 8. Black holes. Cosmic vacuum cleaners. Let's talk about some of the most extreme objects in our galaxy: black holes. These cosmic monsters are regions of space where gravity is so strong that nothing, not even light, can escape. They're like nature's ultimate vacuum cleaners, sucking in everything that gets too close. At the center of the Milky Way lurks a supermassive black hole, Sagittarius A*. It's about 4 million times more massive than our Sun. But don't worry, it's far too distant to pose any danger to us. Instead, it plays a crucial role in shaping our galaxy's structure and evolution. Its immense gravity helps hold the galaxy together and influences the motion of stars in the galactic core. Scattered throughout the galaxy are stellar mass black holes, the remnants of massive stars that exploded as supernovae. We can't see them directly, but we can detect them by their effects on nearby stars. Black holes play a crucial role in galactic evolution. Section 9. The dance of galaxies in the universe. Our Milky Way isn't alone in the cosmos. It's part of a vast and intricate network of galaxies, each with its own unique characteristics and stories. It's part of a grand cosmic dance involving billions of other galaxies. This dance is a mesmerizing spectacle that unfolds over unimaginable timescales. This dance plays out over billions of years, with galaxies moving, colliding, and merging in a spectacular celestial ballet. Each movement is dictated by the invisible hand of gravity, choreographing a performance that is both beautiful and violent. The Milky Way is part of what we call the Local Group, a collection of about 50 galaxies bound together by gravity. This group is just one of many such clusters scattered throughout the universe. Our closest large neighbor is the Andromeda Galaxy, a beautiful spiral about 2.5 million light-years away. Andromeda is not just a distant object in the sky, it's a key player in our galaxy's future. And here's a mind-blowing fact: Andromeda and the Milky Way are on a collision course. Don't panic, though. This event is a slow-motion collision that will take place over billions of years. This cosmic crash won't happen for another 4 billion years or so. When it does, it will be a dramatic event, reshaping both galaxies in the process. When galaxies collide, it's not like a car crash. The vast distances between stars mean that actual stellar collisions are rare, making the event more of a gravitational dance than a destructive impact. The vast distances between stars mean that actual stellar collisions are rare. Instead, the gravitational forces at play cause the galaxies to interact in fascinating ways. Instead, the galaxies pass through each other, their mutual gravity distorting their shapes and triggering bursts of new star formation. These interactions can lead to the creation of new stars, breathing new life into the galaxies. Over time, they can merge to form a single, larger galaxy. This process of merging and transformation is a fundamental aspect of the universe's evolution, constantly reshaping the cosmos. Section 10. Galaxies' windows to our past and future. Galaxies aren't just fascinating objects in their own right. They are vast collections of stars, gas, dust, and dark matter, each with its own unique story and structure. They're also powerful tools for understanding the history and future of the universe. By observing their movements and changes, we can unlock secrets about the cosmos. When we look at distant galaxies, we're seeing them as they were billions of years ago. This glimpse into the past is possible because light takes time to travel across the vast distances of space. This is because light takes time to travel across the vast distances of space. The farther away a galaxy is, the older the light we see from it. So by studying galaxies at different distances, we can actually see different stages of cosmic evolution. This allows us to piece together a timeline of the universe's development. This cosmic time machine allows us to peer back almost to the dawn of the universe. We can observe the formation of the first galaxies and track their evolution over billions of years. We can see young galaxies forming, watch as they collide and merge, and track how they've changed over billions of years. These cosmic interactions shape the structure and fate of galaxies. It's like having a photo album of the universe's entire history. Each image tells a story of a different era in the cosmos. And by studying this cosmic photo album, we can piece together the story of how our universe has evolved over time. We can understand the processes that have shaped galaxies and the larger structures they form. By studying how galaxies move, we can measure the expansion of the universe. This movement provides crucial data on the rate at which the universe is growing. And what we found is surprising. The expansion is accelerating. This discovery has profound implications for our understanding of the universe's future and the forces driving its growth.